In this video, we're going to look at expanding logarithmic expressions, and we're going to focus on these properties of logarithms here. So we're going to apply those to parts A and B in 6.5.2. So the question is, how can you use the properties of logarithms to expand each expression? In part A, we have log base 5 of a squared times b to the 7th. So the first thing we're going to look at is this one right here. We have m times n, and in this case we have a squared times b to the 7th. So what this property tells us we're allowed to do is if we're multiplying, in this case m and n, you're allowed to separate them here using addition. So that's exactly what we're going to do. We're going to take log base 5 of a squared, and we're going to add to that, sorry about that, screen's off a bit here, and we're going to add to that log base 5 of b to the 7th. Let's just clean that up. Sorry for the touchscreen here. All right, so that's that first property. That's the product property. Sorry, missing my words here. So the product property, again, tells you that if you're multiplying two variables in this case, or even two numbers, but we're looking at a and b, you can separate them into two separate logs using addition. Now we don't want our answer to have exponents here. So the next part of this is we have these exponents here, and what that will allow us to do is we can now look at the third property, the power property of logarithms. So that step here is telling you that you can take an exponent, so in this case n, and that exponent becomes a coefficient out front. So what we're doing is moving it from kind of the back end to the front end. So we're going to apply that same rule, and for that first group, the 2 and the 7 are going to get moved out front. So this will become 2 log base 5 of a, and we're still adding 7. Let's fix that. We're adding 7 log base 5 of b. All right, and now this would be our expanded logarithmic expression. The thing you're working on here, again, is these three properties up here. You're just going to work on applying those within a logarithmic expression. Okay, so let's take a look at part B. Part B, we have the natural log of 25 over 3. So one of the first things you want to do, and you might find this a little silly, and you could do this as the second or third step, but one of the things you always want to look at is if you can rewrite any of the numbers, in this case the 25 over the 3, as a number with a power. So what we mean by that is 25 is equivalent to 5 squared. So we're going to rewrite that 25 as 5 squared. Now we'll apply our properties. For reasons I'm not really going to get into, you just really do need to, you're supposed to rewrite those as something to a power property. So here we have the natural log of 25 divided by 3. That's our second property, is what we're going to look to apply. So we're dividing m by n. It becomes m minus n. So let's apply that to this problem. I'm sorry for the screen jumping around a bit here. So it becomes the natural log, that's not an L. It will become the natural log of 5 squared, let's leave that in parentheses, minus the natural log of 3. Now you can put the 3 in parentheses, you don't necessarily have to because it only is the number 3, but it is good practice. Now we'll go back to our third property here. We have an exponent, so remember that exponent gets brought out front as a coefficient. So we would have 2 natural log of 5 minus the natural log of 3. And that's our expanded expression. Again, I mentioned a couple times already, but these three properties are the properties that you're going to work with, and you're just going to apply those to your logarithmic expressions. There's not too much to go into detail with here. It's just going to be those ones. The only real mistake I see frequently is maybe leaving that 25 there instead of converting that to 5 squared. So anytime you can rewrite something with an exponent, you should be doing so. And then those exponents will come up front as coefficients. All right, that's it. Hopefully you have a fair understanding of this, and then using the practice problems, you'll kind of expand that understanding.